Your number?
Ma'am, 102.
102. 25 CS.
2BU22.
22 CS.
102.
Okay.
Yes, ma'am. Ma'am, my screen is visible, right?
Okay, start.
Good morning,
Start.
ma'am.
It is visible.
Yes, ma'am.
It is visible. Start.
Yes, ma'am. Good morning, ma'am. I'm Prathamesh Udoshi. My USN is 2BU22CS102. Today, I will be presenting my project titled Intelligent Adaptive Mock API System. This project focuses on building a system that can learn API behavior and generate dynamic mock responses for effective testing and development. So these are the contents, and the background is like modern software development projects that are present right now. They rely highly on APIs for communication between systems. But during development, the front end and the integration work often gets delayed because backend APIs are either unavailable or unstable. But in the current scenario, tools like Mock API, WireMock, and Mokun, they require manual configuration. That is, the developers have to manually give the responses that they have to type it. So these responses are static and they do not adapt to real API behavior. Additionally, these tools do not support real-time learning, anomaly detection, or contract monitoring, like how much is the endpoints have been drifted from the original. Therefore, like there is a need for a system that can learn API behavior dynamically, like in real time, generate realistic schema-aware responses, simulate edge cases, like the front end should test them, like errors and latency, detect anomalies and contract changes. This would help reduce the development teams and increase testing efficiency. So, these some of the papers and the limitations, like
Only first slide is visible. Papers are not visible. Only first slide is there. Please
yes, ma'am.
hold the slides. Okay.
Now it's visible.
It is visible but not clear.
Uh,
Zoom in. Zoom out.
Now,
Maximize it.
so ma'am, these are some of the papers like which I've referred for the
It is
anomaly
not
detection.
clear. Whatever you are written in the table.
Ma'am, I'm displaying it. Like,
So
I'll
that one
read
you
it
have
out.
to
I'll read
zoom
it
out.
out, ma'am. I cannot zoom in it.
You give the screen slide. It is PPT, right?
Yes, ma'am.
Hmm.
The
Select
slide
that
should.
one.
Okay,
Slide
ma'am.
is that much only.
Yes, ma'am. Like, ma'am, these projects have been assigned to us. Like, so,
We zoom it. It is a zoom in process. It is there. Zoom out. Wait, wait. It is not clear.
PPT I cannot zoom in. This is the control V.
Ah. Now you can explain.
Okay, ma'am, the paper like anomaly detection using statistical methods. Here, what I'm trying to zoom it, no, it's not. So the method they have used is Z-score and statistical model. For that, the limitation is they have used predefined thresholds. Like for every endpoint, it will be a predefined threshold to detect anomaly. And then LSTM-based anomaly detection, like long short-term memory, it is a architecture, neural network architecture. And that what's that limitation is it has high computational
Pratmesh,
cost.
Pratmesh, are you used this screen? All the papers. That is very old one, right? 2000,
Yes, ma'am.
2015,
Ma'am,
21, 18, 19. You should be referred previous 3 years, not the below of that one. Now it is a 26 is running.
okay, ma'am.
So
Ma'am,
you should be
I'll
referred
update those.
25, 24, 23, at least 22. So
Yes,
all are
ma'am.
below 20 only is there.
Yes, ma'am. I update them.
These all the papers are old versions. So it
Yes,
is
ma'am.
already implemented.
Okay, ma'am. I'll update the papers.
Do the literature survey in this manner, which is a updated version it is there. So that one literature survey you have to identify it gap, whichever research gap is pending. So that one you have to implement as a your process.
Yes, ma'am.
These all are already old one, and that is also previous years. That is 21,
Yes, ma'am.
last 5 years back down. So this one, I within the 5 years they can be implemented, right? Somebody.
No, ma'am. Like mine is a combination of all of them. Like these are just for reference I've taken, ma'am.
So you
Like we
refer
have
the
1 year.
okay. You refer the papers, which is the newer one. Okay.
Okay, ma'am. Okay, ma'am. I'll
Previous
do it.
3 years. Okay. Next.
So, ma'am, the research gap that I've identified is like the tools currently which they have used, like Postman API,
That gap I am
WireMock.
not getting. Screen slide. You have to change it.
Yes.
Hmm.
So, ma'am, the gap is like in existing tools, there are Postman API, there is Wire API, and Mockhoon. They rely on manual configuration of mock endpoints, leading to static and non-adaptive responses. That is, the developer has to himself give the response and structure what all has to be done. And if there is any changes in the responses and all, these current existing systems cannot detect them. So they lack the ability to learn from real traffic, which is flowing currently in the API traffic. They don't identify them. And the missing features are there is no adaptive mock generation based on API behavior. Like the observed one, it does not generate those. There is no support for dynamic edge case simulation, like error responses, variable latency, schema variations. So the front end can test them and they could see how well their product or project is working. There is lack of intelligent schema learning. What I have implemented is like it also understands the schema of the response, request and response. It sends the response in that schema itself. And there are no systems which have adaptive learning from real API traffic. There is no intelligent mock response generation. It learns from the schema itself and generates responses when the real backend is down. And in real-time anomaly detection and scenario simulation, even those are not being implemented by like Postman, WireMock, and Mockhoon, the tools which are currently existing. So a unified live server, like there's also a dashboard like to identify what all endpoints have been learned and all. So this is the gap like I'm trying to solve in my project.
Next.
In the system architecture, so first, ma'am, it's visible, right, ma'am, architecture?
Yes.
Okay, ma'am. So here the browser client, when they send a request, the backend is using fast API because it supports asynchronous. So there will be two modes, proxy mode and mock mode. And in proxy mode, it learns endpoints in proxy mode. It lets it pass through the server and it sends to the real backend. And through real backend, it sends the response back to the client. In this process, it learns the endpoints, it identifies the schema, it identifies the average latency, error patterns, everything, and it stores it. So next time when the real backend is down or when they are updating something and the front end wants to test their APIs and do like test how well it could handle errors. In that, they could access the mock mode. In mock mode, it tries to get those endpoints back from the database and then simulates a schema-aware response to the client. And in that process, also, it does the anomaly detection. Like if there is a high anomaly detection, and also drift detection, if the endpoints there are any variables changed and all, so it will detect that also.
Okay.
And then so far, I
Yes.
have
Okay.
implemented the API request handling and normalization. Like it will capture the API response and request. It will normalize dynamic endpoints. Like if there is user slash some number, it will identify it that it is an endpoint and not it is a unique one. And it will store the structured endpoint in an database. Like I have used PostgreSQL for it. And then schema learning and mock generation. It will uh, like it will get a copy of the request and response. It will understand the schema of it, and it will support edge case simulation. Like I've added some case scenarios where you could forcefully, like make latency, increase the latency or increase the for not for errors and all, so that to front end can be tested. And then the proxy and adaptive learning engine, like forwards the request to the real backend. The proxy in proxy mode, it has to send to real backend to capture the request and response, and it performs statistical analysis to detect the anomaly. Like currently, it is using Z-score analysis, and it enables fallback. Now, if the backend fails suddenly, it will get shifted to from proxy to the mock mode. This has been also implemented.
Next, so give me the demonstration.
It's visible.
Yes, is it?
Okay, ma'am.
Screen is demonstration.
Yes, ma'am.
It is the only PPT is showing summary slide.
Yes, ma'am. I'll share. I'll update this. Mm, now it's visible.
Yeah.
Okay, so this is the platform, and here what we have to do is we have to send our requests from the front end to this, and from here it is sent to the real backend,
Okay.
and from the real backend it will send again request passing through this to the front end. So in that process, this will learn the endpoints. It will learn the schema, it will learn the endpoints, and all it will store in the database. And this is the main console where it will record all the endpoints. Like if any endpoint is passing, it will tell us what's the proxy and what all requests have been passed through it. And here we have to enter the target, that is the real backend URL. So it
Hmm.
will go to the real backend.
This is the proxy.
Yes, ma'am. Currently it is in proxy mode.
Okay.
So in this it will learn, it will
That is a
understand.
proxy type.
Yes, ma'am. And in mock mode, this will give the responses to the front end. The real backend, if it is down or they are updating something, this will provide the responses. Like in tools like Postman and all, ma'am, there we have to manually give the responses what we want. But this understands, learns it themselves, and it gives the responses by itself. So the front end does not waste their time in development process.
Okay.
I mean, these are the endpoints it has learned. And next, I'll be implementing an LSTM training process. Like now, for detecting anomaly, it is using Z-score. That is how far an endpoint is from its mean compared to the standard deviation. So that is currently is detecting the anomaly. Here it is, the anomaly is detected. And I'll be using LSTM, that is long short-term autoencoder. In the next review, I will show it.
Hmm.
And these are the endpoints that have been learned. This, like there was some project I tested. These are the endpoints, and this is the average latency. This is the error rate. Like 50% it has given error rate, and these are the request schema. What all? This is the response schema, and then fast API supports Swagger UI. So these are all the endpoints that have been learned, and you can try it out here itself. For the conclusion, this is a system that simulates API behavior from learning real-time traffic. It reduces dependency on backend systems.
Demonstration screen is gone.
Yes, ma'am, I'm showing the summary screen.
So I wanted to check the client part.
This is only the client one. He'll be only using it. Just a second.
Yeah.
This is only the client one. Here only he has to log in, and he has an
So
project
it
in
means
the
that
development.
client and proxy communication is going through.
For that, I'll have to connect the project, another project.
Yes.
Yes, in 2 minutes. Hello, ma'am.
Huh.
Ma'am, could you like it will take 2 minutes until could you finish Pranit's or you'll wait for 2 minutes. I'll set up the other project.
You required how much time?
Like in 5 minutes, I'll set up the other project. I have to connect it.
You finished that one.
Okay, ma'am. Two
After
minutes, ma'am.
that, I will connect to Pranit.
Yes, ma'am. 2 minutes.
Huh. Do it little bit fast.
Yes, ma'am.
Okay.
So from next, it will detect the how much monitored. Like now, I just tried one. That is the analyze. It is showing one have been monitored, and the
Hmm.
health score it is based on the drift detection and the anomaly detection. And drift in the sense if I change any variable name and all, the if I'm using tools like Postman and all, where the response is static, it won't give me what is the change. But here, it will give me the response, like it will show me that it has been changed. So
Okay.
that I'm currently working on, and I'm also working on the LSTM neural network. Currently, it detects anomaly used on the Z score. So I'll be implementing LSTM, which will be more efficient than Z
What is the
score.
LSTM? How it will be work?
Okay, so LSTM is long short-term memory autoencoder. So what it does is it will first any given set of endpoints and all, it will convert it, it will encode it into a compressed format. And
Hmm.
then the decoder it again converts back to the original.
Hmm.
So if the original and after it decoded, they both are same, then there is no anomaly. But after it compresses and then it again decompresses, and if there is difference, like it is varying very much, then it will trigger an anomaly.
Hmm.
So this is
It
updated.
is
But
a new notification.
yes, ma'am.
It is giving triggering. If it is coming, the
Yes,
difference is
ma'am. Yes, ma'am. It is if it is to more anomaly. This is the updated. Like currently, it is using Z score. It will just identify the response size, the latency. It will only focus on the statistical part, the Z score. After implementing LSTM, it will analyze everything like a complete endpoint. It will compress, decompress, and then it will calculate the reconstruction error. So that will be more
okay.
accurate. By review 2, I'll be showing you that.
Okay.
Yes, ma'am.
Fine.
This is the summary. Like future scope, I am planning to use it,
So
make it
whatever you are
multi-user.
presented, you have to record it and upload in the shared link.
Yes, ma'am. It's a recording.
Again, you also be start reporting of the your project also. It will be shortly we will be give the notice of that one.
Ma'am, in the internet platform, I say,
What?
where we have to project
It
report,
is
you're saying.
already shared link is it is there already Sheetal Kokota madam is shared.
Yes,
So
ma'am. The
through that
recorded
link
link I
you
have to
have to
share in
upload
it.
it.
Okay.
Okay.
Yes, ma'am. Thank you. Ma'am, I'll ask Pranit to join.
Okay, you ask them to join it.
Okay, ma'am. Thank you, ma'am.
Okay.
यहाँ लगा